Okay, these are 4 questions on limits, and they are all solved using different methods. This one I will call it the substitution. This one I will call it the factorization. This you'll see 4 different methods. Okay, and we'll see using the conjugate. Actually, essentially they are the same, but it's just this one is knowing by going by this. Okay, so 3x factorial greater, of course, 2 greater than 2x factorial, so on and so forth, to hope you get 3x, so 2x, so and because E is a number between 2 and 3, and so we have x 5, for example, x4, so x2, 3, so on and so forth. So this is just example that means to say that a polynomial goes to infinity slower than a power. Okay, a power, and the power, depending on the base, the larger the base, the faster the power goes to it. I mean, faster the whole term goes to infinity, and then factorial is even faster than powers. So we have it here that okay, we do the first one. This type of is easiest. Okay, so let's say if when we substitute this for this kind, we just when you substitute inside, we get 4 square root 4 is just 2 minus 8. Okay, 2 times 4, 8 plus 9. Okay, over 1 minus 4, 4, 16, 16, 4, 64. Okay, and E 4 minus 4. So this one, 2 minus 8 is 6, 6 plus 9. 2 minus 8, no, 2 minus 8 is minus 6. Minus 6 plus 9 is 3. And e to a power of 0, 4 minus 4 is 0, so e to the power of 0 is 1. So 1 minus 64 is just minus 63. Minus 63 equals to 3. So this one is minus 21. So when we get a number like this, which is a constant, we know that the limit x approaches 4 for this expression is get to 1 minus 21. But I see that sometimes substitution does not give us a constant. It gives us something like 0, 0. And that is when you cannot trust this answer. The limit does not really go to something like this. This is undefined. We'll show you what I mean now. So let's say if I substitute half directly inside, I will have half square equals to, I'll have half square equals to 1/4 plus half minus 3/4. Okay, and over half square is 1/4, so 1/4, 2 over 4 is just half. Okay, plus 7 over 2 minus 4, which gives me essentially, okay, this is 2 over 4, 2 over 4 plus 1 over 4, 1 is 3 over 4, 3 over 4 minus 3 over 4 will give me 0. And this one half plus 7 over 2, because 8 over 2, 8 over 2 is 4, 4 minus 4 is just 0. So 0, 0, but we cannot trust that this is the limit. We must look further than this. Okay, so whenever we get 0 over 0, we must look further. We cannot trust that this is the limit. If you get a constant, it is fine. So, and let's say, what if you get 0 over a constant, that you can trust it to be the limit is 0. If you get something over 0, constant over 0, okay, that is undefined. Okay, so we have come back to here. So before, the trick to find this kind of limit is first to simplify the expression, actually to factorize it, and we see if there's any common factor. So what I'll do is I'll multiply 4 on top and below to keep the, so this top will become 4x squared plus, because I do not like to see a fraction over here, so 4x minus 3. Then bottom I must also multiply by 4 in order to keep the same expression. Okay, this is the same expression. So then I'll continue to factorize this. Factorize this, I get this is 2x and 2x and 6 minus 2 will give me 4, so minus 3, this will give me minus 6x. Okay, so I want 6x. 6x minus 2x will give me 4x. So minus 3, okay, 4x squared. Then over this one 4. Okay, if I get a 2x and x over here, so 2x I want 7, so I get 2 times 4 will give me a 8x. 8x minus x will give me a 7x, and 2x squared and minus 1 times 4 will give me minus 4. So this is the correct factorization. I realize there is a common factor top and below, so I cancel it away. So just now we got 0 on top and 0 below because we substituted a half, and half times 2 is 1, 1 minus 1 will give me 0. Same thing for this term. So 0 times anything will give me 0, and 0 times anything will give me 0. So 0 on top and 0 below. That's why we got the 0 over 0, which is not reliable. In fact, the limit does not goes to 0 over 0. Let's see. When we substitute half, we say half times 2 equal 1, 1 plus 3 is 4. So I have a 4 over here, and half plus 4 is 4 and a half. 4 and a half is just 9 over 2. Okay, 9 over 2 times 4, you get 18. Okay, and that will give me 2 over 9. So this is the actual limit. What about if you got a conjugate like this? It's not easy to factorize, but I could if you get the expression like this, I mean, if it's not easy to factorize, so I'll use the conjugate method to simplify this expression. Because for this, if I substitute 3 directly, I will also get a 0 on top. If I substitute 3 directly below, I'll get root 9. Root 9 is just 3. 3 minus 3 will give me 0. So when we attain this, we must know that this is not reliable as the limit. So what do I do? So first thing I will do, this equals to limit x approaches 3 still. Then I will multiply the top and bottom by the x minus 3. Okay, multiply the top by 3 plus root 12 minus x. Essentially, this is the conjugate of this. Remember this equation, a plus b, a minus b give me equals to a squared minus b squared. So this will help me simplify the term below. Let's see how it helps me. So if I have a 3 minus root 12 minus x, and I multiply to the same term, 3 plus root 12 minus x, so it's on top and below. Okay, this is the conjugate of this. So when these two are same, I'm actually essentially multiplying by 1. I'm not changing this expression. So but when I do this, when I multiply this on top and below, what I achieve is that this is actually a minus b, a plus b. So same thing as this, a minus b, a plus b, which is a minus b, a plus b. When I multiply together, I get the first term square. I get the first term square, which is 3 square, which is 9, minus the second term square, so which is 12 minus x. Because the square of a square root, we just remove the square root and let it be 12 minus x. And that I'll have x minus 3. Same thing, we still have 3 plus root 12 minus x. And this one, when bottom simplify, I realize is 9 minus 12 is just minus 3, same as the above. So 9 minus 12 minus 3, and minus times minus x will give me x. So this term is actually the same as this term. I cancel it off. So I get limit x approaches 3 for this term. So when I substitute the 3 inside, I get 9. 12 minus 3 is 9. Root 9 is just 3. 3 plus 3 is just 6. So I get my limit is 6, which is not the one that we found earlier as 0, 0. This is unreliable, as I mentioned again. So how about for this expression? So you look at this expression and see which is the largest, which is the term that goes to infinity the fastest. This method is only applicable to where you get the infinity. So when it has the infinity, these terms, which is the fastest? E2x is faster than EX, of course. So for example, 32x is of course faster than this one. So let's say E2x is the fastest, so I can just ignore all the rest because these are insignificant. In the face of E2x, all the rest of the terms are insignificant because they goes to infinity at a much slower pace. So that means I only look at this part, and that means the E2x can cancel away with the E2x, and I just get this is the same as this. Okay, so and because I just cancel away, we get just 200 over 16 is the limit for this expression. So what you can do is, let's say we could have other examples as well, and for example, limit x approaches infinity. Sometimes how about negative infinity? What if I had changed this to limit x approaches negative infinity 200 e2x plus 4x squared, okay, over 16 e2x plus 3x cubed. What if that's the case? Note e negative infinity changes the game, because e negative infinity, when this happens, this is just 0, because e to the power of negative infinity is a term that is close to 0. So this term goes to 0 and this term goes to 0. So this becomes more important. Okay, so the e exponential terms goes to 0, rather these two terms become more important. So x squared and x cubed, comparing the two of them, x cubed moves to infinity faster than x squared. So we have a very large negative value at the bottom and a smaller value at the top. So that means I will have a very large bottom and a very relatively smaller top, and that will give me equals to 0. Okay, because x squared would cancel away, so then I will have negative infinity. So this is a value that is slightly less than 0, because it's a negative value. So with that, I end the tutorial on limits.